Hello everyone, welcome to Norsden Land to Neso episode 41 with Dr. Aeronautics. So we are going to do the Beach 4 mission today. The Beach 3 mission was a success. We got into a parabolic arc and successfully survived it and were recovered and everything else. And we also invented the helicopter. Which is just in time for that. So that's not good enough, though. We want to go orbital. And in order to go orbital, we need to scrap the rocket that we had and build an even bigger one. So here is the equivalent of the Mercury Atlas. This is a really big rocket with 8 different engines. And it has little side pocket engines here, which help conserve the horizontal cross section, so that as it flies through the air, it's a lot better in terms of air resistance. Now we're actually not going to ride in it today. There's no astronauts going on board. This is simply a mission to put a satellite up into orbit. So, as we mentioned earlier, in earlier episodes, orbits are defined as speeds that are so great that you clear the Earth before you hit it, and then you just continue falling around it. If planets weren't round, orbits would be impossible, because no matter what speed you go, eventually the planet's gravity would pull you down to the planet. But thanks to the Earth being round, we don't have to worry about that, because we'll just fall right off the edge and then continue falling around it. Although we're not doing it. So let's go over the mission objective, shall we? On top of this is not a capsule, but a satellite called Image 1. And it's full of cameras, and the plan is to launch this thing up into orbit, and some of the science guys back in the lab over there said that after we leave the atmosphere, the Earth will continue rotating under us and allow the orbit plane to be exposed to different parts. Therefore, if we launch at 40 degrees north inclination, we ought to be able to see 2/3 of Norsden Land within about 12 hours. So the plan is to actually go up there and improve these maps that we have now based on solely ground observation. We'll actually get pictures of what this looks like, and we can create zoomable maps that are 100% accurate, because they're taking pictures of the actual thing that we're trying to create a picture of. So that's the plan. I don't anticipate on running through the countdown on video, so I'll do that on the side. Skip all that stuff. So, just to double check that we have everything together, once we go through the startup sequence, we're going to do a ground lockup test, which is where we try and get the system to recognize that we're trying to read it, and if that's successful, then we can proceed with the launch. We're going to track the launch as it goes all the way past all of these islands over the horizon, and we're going to lose it because the rocket, as opposed to the other one, which just goes straight up. All the rockets before now have gone straight up and back down, but to go in an orbit, you have to go sideways like this to get enough speed to clear the Earth. So it's kind of like this, except I don't apparently have enough jumping power to clear that in one go. But anyway, so it'll go up, and then all of a sudden, as it starts moving over, we're going to track it all the way to the horizon, and if we're lucky, we'll get into orbit so that we go through the horizon. Then there'll be about 80 minutes or so, I'm told, before we won't see anything. And then 80 minutes later, we're going to be estimating the time that the spacecraft will come up over here. Now the thing is, it's not going to come up in the exact same place because the Earth would have rotated by that time, however far it would, degrees in 90 minutes. So we're going to be looking for it in the west, actually, and it's not going to pass right over. If we launch it in this direction, when we see it, we should be catching it about here. Should be going up, not all the way, and then just go down to the other side. And then we'll lose it for 12 hours until it starts coming up over here again. Actually, wait, no. It would be coming up over here. Hang on a second. This is east. Let me see. If we launch it, it would... yes, we would be picking it up again over here. No, I was right the first time. We'd be picking it up here as it goes over that area, and then the next time we'll get it right over the facility, and then the third time we'll probably get it back in here, and then we'll lose it again for 12 hours. So that's how orbit tracking works, and unfortunately the thing on top here is going to be a total loss because it's never coming back down again. Well, it will eventually due to air resistance, but very, very slowly. We're going to try and get this thing launched up above 240 kilometers because that's what we need for a few days. We're hoping to get a few days use of that out of it so that we can hopefully map Norsden Land and map the rest of the world. That way we can sell people pictures that we take of the Earth and be like, hey, want a picture of your country? $500,000? Yes, thank you. So yeah, and we have to verify orbital elements and do orbital determination, downlink pictures, all that shaz. We have to do... Wow, I thought I saw a creeper there. We have to do all that stuff because I want to know what the initial orbit is when it gets up there. I want to know if we're going to see it again. So, without any further ado, I will go ahead and spend the night right here, or not, because it's not going to let me. And I will see you guys on the pad the next morning for the ground operations test. Okay, so here we are on the launch pad. The rocket is over there. We're standing by now for launch. We're going to do a quick test now of the flight data to make sure that we can receive data from the satellite here, or soon-to-be satellite. So we went alt, airspeed, temp, pressure. All of those are fine. Okay, altitude seems to be about 20 meters. Airspeed 0. Temperature is 280 Kelvin. That looks good. And the actually no, that's 288 Kelvin. Fair enough, and the pressure is about 101 kilopascal. Perfect. Alright, we are ready to proceed with terminal count. Nominal liftoff is scheduled for 15:51:50. So that's just a little bit over 3 minutes away. Should be about 4 minutes, actually, by my calculations. 47 through 50. Gonna go ahead and set my field of view down to where I normally like it. And we have a good view of the launch site right here. So it looks like about 160 seconds from now. And launch should be targeted for the 400-second mark in that counter, which is 160 seconds or thereabout. Now that should not be right. It should be... Wait a minute, hang on. 160 seconds. Yeah, that should be right. 160 seconds after that point. So 160 seconds is 2 minute 40 seconds. It's 15:52:50. Yeah, because we've already passed 51:50. Okay, we may have a false countdown here because of my inability to count time when watching it on a clock, so go figure. So I'm going to do my best to attempt to do this. So should be at about T-minus 15. And let's see if I get it right. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. We have ignition and we have liftoff! I actually got it right! And we have liftoff of the Mercury Atlas with the Image 1 satellite destined to view Norsden Land from above. Look at that thing go! It's just shooting up and away. That is a truly beautiful sight right there. Five kilometers in altitude. One minute into the flight. Okay, airspeed is now 700 meters per second. This is 1/10 the amount that we're going to need to achieve orbit. The altitude is still climbing. We're now at 20 kilometers in altitude. Range is falling as it's passing the outer islands there. Looks like we've hit stratopause. Altitude is now 30 kilometers. Airspeed is now 1,500 meters per second. We're now about 1/6 of the velocity that we're going to need to achieve orbit. And, we can't see it anymore. Might be able to... No, I guess it's gone. So, when the video went, we lost the signal with the craft, and it's been lost for some time, but it's coming back now, and thanks to some satellite spotters in, what's that place called? Westport, we ought not to have to worry about, there we go. We ought not have to worry about the orbit. They say that it's good, which means we should be seeing it come around here. Now, before I do some quick estimations, I want to turn... Here we go. I want to turn our viewfinder around so we can look for it when it comes back up over the horizon. And let me see where we are at. So let's see if I really know this off the top of my head. I believe the period of an orbit is t equals, was it 2 pi times the square root of the semi-major axis cubed divided by g times the mass of the object. In this case, it's the Earth. So the radius of the Earth is 6378 kilometers. If they said our orbit was good, then we should be at 240 kilometers. Which means 6618 kilometers would be our semi-major axis. And then we got to divide that by the gravitational constant, 6.67 times 10 to the minus 11, some crazy units that I don't know and I don't care about, times the mass of the Earth, which is 5.98 times 10 to the 24 kilograms. Get that quotient, take the square root of it, and multiply it by 2 pi, and we should be getting something around an hour and a half, according to my testificates. And I come up with 89.26 minutes, which is believable. So that means the initial period of what it looks like is 89 minutes. And just about 20 seconds. So now, the satellite spotters said that they found it at 174 degrees east at 2302. So that's the ephemeris that we're working with. So we're at 80 degrees west using the current coordinate scheme. And that means that there is 180 minus 80 plus 6, or 106 degrees of longitudinal separation. Now, you can't simply say that naturally the spacecraft covers 1 bit of longitude every minute, because it has an inclined plane, so that amount varies. What we can do is relate it to the orbital period constant. We know that in 45 minutes, it travels 180 degrees. And we're at 106 degrees. So we can start rounding off. So if you say it takes 45 minutes to go 180 degrees. The speed at which it's transversing these is a cosine function. So what we're really looking at here is a differentiation problem. So it crosses the fastest amount of longitude, the quickest rate of longitude, is at the northern and southern edges of this. And being at 106 degrees off of where we are now, so 106 degrees, let's see if we can get a sine of 28 degrees. Now let's see if we can get a sine of 28 minus 106 and see what we get. Okay, so naturally at that time they were giving us the information. It was either at the north or the south vector of the planet, which is good. So that means that we were at maximum speed, and we're going from maximum speed halfway to minimum speed. So halfway would be the sine of 45, which is 0.707, and the cosine of 1. So now technically what we got to do is average these out, and the way you do that is with an integration problem. So we have, I guess it's the integral of cosine of x between, what would that be? Or is it arc cosine x? Is it cosine or arc cosine? We're trying to find the area under the curve, so it's cosine. Actually, wait. No, it's sine. Okay, so sine x between what would 90 degrees? Pi over 2, pi over 4. So we get negative cosine x between pi over 2 and pi over 4. So cosine of pi over 2 is 0, and then minus, there's a subtraction out there that's going to make a double negative. Now we take the cosine of 45 degrees, we get 0.707. So positive 0.707 times the maximum rate of motion. I'm going to pause the video while I try and figure out how to quantize that. Okay, so I think I figured out some math that might work. So what I did is I figured out, okay, well, what's the rate? And then average the latitudes to figure out the difference in spacing between each degree of longitude. And you say that you're going 7 kilometers per second east at the maximum east-west speed. At that latitude of 30-ish degrees, which is the average, we're covering 13.74 seconds per degree longitude. There's 106 degrees separating between here and there, which means that 232600, it should be where we are. Meanwhile, I've pulled up the satellite's frequency, and it's awaiting our call. We're calling out for it now, and hopefully it will do the classic knock and answer. If it doesn't show up, I guess we're going to have to wait up to 12 hours. And if it still doesn't show up, then we're going to need some more professional radar done to say, okay, well, is it just our thing is broken, or are we in trouble? So, one of the two. I am going to pause the video now until we lock up, because I don't know when we're going to. I assume it's going to be at 23:20 something, because we usually have about, according to the guys, there should be about 5 to 6 minutes before we see it before it gets overhead where it can talk to us. Good news, everyone, we've successfully locked. We have a distance now, we have a velocity, and we have a vector now. So using this, we should be able to plot the location of the system. Let's see if we can, should be able to find, oh, looks like it just went overhead. Yep, there it is. Okay, so it's just over us now. I guess it's not visible, but that's okay. So, looks like it swung down to like 280 some. So that would be our altitude. So yeah, there you can go, the 300 some kilometers moving off. Here's the range where we should be able to see it. And it looks like they got the altitude pinned down to 247 kilometers. And, excellent. The data streaming in. We should be getting our pictures now. Our very first pictures of Norsden Land from space. Still going at 493. CVEL, I believe, is the velocity vector. How much of a difference there is between us and it. And that is going up because the angle is changing. It happened very quick. Like I said, I was just looking at it, and then all of a sudden, boom, went right overhead. I knew as soon as that velocity went negative that it had gotten as close as it was going to get to us, and then was now going ahead. Wow, 800 kilometers, and we still have the signal. That's really good. That's really, really good. Okay, so, yeah, we're getting close to the point now where we're going to be losing the signal. But that was pretty good. Velocity is looking good. That looks like an orbital velocity. Oh, and we've just lost the signal. Right at sunset. How about that? Well, I am ecstatic about this. Let's go take a look at the pictures that we've downlinked when they're processed. Okay, so we've got the pictures down. We've got 7 pictures here. Now, the way these are organized is that if the ACS system on the spacecraft is working right, then the prograde, the direction we're heading, which would be east, would be here, east-ish. This would actually be southeast. And northwest, or the retrograde vector, would be in this direction. So if this is correct, this should be northwest, and this should be southeast. And that kind of looks like jungle there. And then we have another picture here, which looks like it could be forest of some kind. Then we have a picture that looks like all water. And another picture of all water except for that little island. And yes, actually, is that the same island? No, that's not. Then we have another picture, which is another island, it looks like. Actually, a grouping of islands. See, we are learning so much about the world. The mapping abilities of Norsden Land are going to go off the charts, because all we need to do is just snap, 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 collect all these pictures together, and then create a montage that is just 100% accurate. And here's some more islands. These look unrelated to this one. So here's 1, 2, 3. This is probably the Tetrium Sea. That's a pretty good twin pair of islands. I should see, and now where it comes to the naming part, because we see these things on the image, and we're like, okay, well, we can name these because we know there's obviously a rose patch here and a dandelion patch here, and there's some stuff down here. I don't know what this stuff is, but there's something down there. And then there's this. Oh, I know what this image is. So right at the very moment that we were looking at the at the exact moment that we were looking at, and I was like, oh, it went right overhead, took a picture. Where am I? I was. Looks like I did. My station didn't show up. I was in the. I was getting my data fed from the Space Flight Tracking Data Network, but I was over in one of these offices over here. Some of this looks empty for some reason. Oh yeah, I know where that is. I know why that is. Yeah, so here is the actual Space Center taken from space. And it looks like this picture was actually snapped directly above pad 30. because this is the giant gantry crane and tower that's used to suspend that. And knowing how tall this thing is, and then being that far above it, so that it looks like this, is crazy. So here's the crawler tracks for our launch pads. Here's the launch control center. This would be the admin building. This would be the vehicle assembly building, and the orbiter processing facility would be here. This would be pad... That's pad 30. This would be pad 10. That's pad 20. And that's pad 40. Spaceflight tracking data network, some island, and the southern forests. Hey, and look! Here's even route N1. You can actually see N1 snaking its way through the forest. And then actually going down here. Is that N1? I didn't think N1 went that far... Oh wait, no, because that's the Tetrium Sea right there. This is all the way down to the end of the peninsula. We can see all this in one shot. And then here's the lake at the Space Center. So yeah, the mapping capabilities of Norsden Land are absolutely off the charts now. And we've achieved orbit. So with that pat on the back, I guess this is a fitting ending until episode 42. Episode 42 is an autonomous run of the Beach 6 mission, called Beach 5, where we launch into orbit and then command the spacecraft to leave orbit, and we have to test the re-entry heat shield, because the re-entry that I dealt with launching on Beach 3 is going to be absolutely nothing compared to the one that I'm going to have to deal with on Beach 6. So we're going to have to hope that it's ready for that. And that's about it. So I thank you guys for watching this. I hope you enjoyed it as much as I did, seeing all this stuff. If you're interested, put some comments in and asking for it, and I will create a picture slideshow and upload it to YouTube of select areas on Norsden Land. If you want to see what some part on Norsden Land looks like from space, let me know, and I'll take some pictures of it and put it together. Create some maps, and oh yes, we can finally create a 100% to scale map of New Venice. So I'm pumped about that. So next mission is Beach 5, and I will see you guys next time for Norsden Land and Neso episode 42. Not sure if I'm going to show Beach 5, because it's pretty much the same as Beach 4, except it autonomously leaves orbit and re-enters. Maybe I'll show a little bit of Beach 5 on like an interlude episode, not technically a full episode. But anyway, I will see you guys later. Bye.